Okay, howdy everyone. So today I'm going to be giving a basic explanation of what Python is, how it works, and how to install it for your atmospheric research. So all of these tutorials are going to be relatively focused on lightning mapping array since I'm doing it for Dr. Logan's research group. However, if you're just looking to pick up with Python for your own projects, you will certainly learn a lot. So with that, let's get started. First of all, I'm going to be giving a basic explanation of what Python is, what modules are, how to install them, and what environments are and how they work. So if you already know all of that, then feel free to skip ahead to the timestamp that is going to be on your screen when I edit this. So getting started, Python is a free and open source programming language that is designed to be really extensible. It can be used for just about anything. But on its own, if you just have Python and nothing else, it's basically useless. The way Python works is once you have the base Python installed, you can then install any number of community-based modules or packages, as they're called. And these packages range from, you can think of a package, I'm sure it exists. There's, for example, NetPy, which is for meteorological calculations. There's CartoPy, which is for making maps. There's Matplotlib, just general plotting. There's all sorts of very niche ones as well. There's a specific one called ARM-PyArt that we'll probably be installing eventually that has to do with like specifically just for reading in and plotting radar files. There's little ones like Tabulate, which just make pretty tables. There's plenty of untold modules. There's modules for communicating with devices over USB. There's modules for networking. There's anything that you can imagine, there's a module for it. So these Python modules are really useful, and they're developed by the community. So Python itself is just kind of like the base like programming language, and then anybody can develop a module and allow it to be downloaded by anybody else. And so this creates an environment of people sharing code and working together on things, which is part of what makes Python so powerful, is that you have all these niche modules that can do basically anything you can imagine. So we're going to be installing probably all of these modules today, but don't worry if you don't know them. You will be familiar with them as you learn. So where do we get these modules from? So packages are I'm using packages and modules interchangeably. They're basically the same thing. I don't know if there's any differences. I've heard them called both things. So these Python packages are installed by what's called a package manager. And package managers will either look in by default, they will look in the Anaconda repository, which is the older and kind of more widely used, more standard repository, or they will look at the Condaforge repository, which is the newer and more open community sort of supported one. If you can't tell, I have a favorite, but we'll get to that in a minute. So you tell your Python package manager, which a Python package manager is basically just a program that it does exactly what it says it does. It manages what Python packages you have installed, and if you want to install a new one, it installs it for you. And sometimes Python packages will depend on other Python packages, like you need to have one installed before you can install, like if I want package A, it will require package B to be installed at the same time. Your package manager will handle that. If you say, I want package A, then it will say, well, but you need B too, so I'll go get that for you too. And it's just general organization. So these packages are hosted either on the Anaconda repository or on the Condaforge repository. And they are managed by package managers, either developed by Anaconda Incorporated in the case of the Anaconda repository, or by the community in the case of Condaforge. So there's the Anaconda package manager, Miniconda package manager, which fetch from the Anaconda repository. And then there's the Miniforge, MambaForge, MicroMamba. There's probably plenty of others because these fetch from the Condaforge repository, which is generally considered to be more open. Today, I'll be going through how to install the Miniforge package manager. I kind of have a list of the differences here, but the main thing is that the Condaforge repository of packages has access to newer versions, and sometimes those are necessary for what we're going to be doing. So I'll be doing the Miniforge package manager today. The reason for that is just because it's very similar to this Miniconda package manager that's more widely used. And so if you're ever looking up a tutorial for something and you don't know how to do something in Miniforge, you can just look up the same tutorial for Miniconda and everything should just be the same. Again, if anybody needs any help with this, just kind of let me know and I will hopefully be around to help you. So I'm going to be setting up Miniforge, and yeah. So one of the other great things about a Python package manager is that once you install the Python package manager, you can create what are called virtual environments. So basically walled off like sandboxes of different versions of packages. So like I have, for example, environment 1 here, which I might use for radar data visualization, where like, let's say I need specifically I need Python 3.10 for some reason. There's a specific feature that I want to take advantage of, but I don't want to use 3.11, the bleeding edge. And then I have a series of packages that I might use for radar visualization. Environment 2, maybe one of these my code hasn't been updated for Python 3.10 yet, so I still want to use 3.9, and I will say I'm reading in some netcdf files. So I've got xarray and metpy and matplotlib, and I'm making maps of those or something. And then like for environment 3, let's say I want to be on the bleeding edge of Python development with Python 3.11, and I've got pandas and tab. I don't know. I was just making stuff up. But the point is, you can set any of these 3 environments as active, and while that environment is active, you have access to those packages and only those packages. And you can switch between them at any time. But this just helps with general organization, because if you make a mistake and install something you don't want to, then it doesn't make a mess in any of your other environments, and it's generally just organized, and also allows you to have multiple versions of packages installed at the same time. So I realized that was kind of a lot, so I've just kind of boiled down what we'll be doing today. So first of all, I'll be installing Visual Studio Code, which is my personal favorite code editor. And you will need a code editor to edit code. Hopefully that makes sense. And if you already have a code editor installed, if you have Spider or Jupyter Notebook or something like that, and you like what you have, feel free to skip that. I'll also be installing Python and a Python package manager via the Miniforge installer. So again, we'll get to that when we get there. And then once we've got the Python package manager installed, I will create an environment specifically for atmospheric science research, and then we can install some useful packages to that environment, and ending with me dropping into a shell and importing one of the packages. And then once you're there, you should be good to go to start coding. So the way I recommend watching this is I will have timestamps edited in afterwards. I'm going to be doing this tutorial essentially 3 times, once on Windows, once on macOS, and once on Linux. So based on what computer you're currently sitting behind, if you're behind a Windows machine, you really only need to watch the Windows portion. If you're behind a Mac or Linux, same thing there. If you, for example, already have Visual Studio Code installed, then you can, or Spider or Jupyter Notebook or whatever, then you can just go ahead and skip to where I go to installing Python. If you've already got a package manager, and it doesn't necessarily have to be Miniforge, that's just the one that I'll be showing today, because that's the one that I think is most friendly to beginners, and also has enough features that it'll be useful. So if you already have either Miniconda or something like Mambaforge, or even full Anaconda already installed, you can feel free to skip that part and just skip straight to creating an environment. I recommend that everybody watch the creating an environment and installing a package, just because that way everybody's on the same page with what I'm going to be making an environment that I'm going to switch to every time in probably every single future tutorial. So yeah, with that, go ahead and skip to wherever you need to go. And I'm going to go ahead and get started with installing Visual Studio Code. I'm going to start out with Windows. So thanks, and get it. Windows right now. If you're using a different platform, go ahead and skip forward, like I mentioned, to either macOS or Linux, depending on what kind of computer you have. So Visual Studio Code is a code editor. I personally like to use it. However, not everyone does. And if you prefer Spider or Jupyter Notebook or any other kind of code editor that you prefer, Atom, whatnot, if you have a code editor that works, you can go ahead and skip forward to the part where I go to installing Miniforge and creating the environment. But if you don't have or don't like your current code editor, or just want to use the same one that I do, you're going to want to go to code.visualstudio.com and click this download for Windows button here, and it will go ahead and download. And I'm going to hide the zoom controls because they are in my way. All right, and go ahead and open this up and accept the license terms and install. You're going to want to create a desktop icon probably, and I would check all of those, yeah, and go ahead and install. And you can go ahead and click finish. It's going to launch, but we're going to go ahead and minimize this for now as we don't really need it yet. Now I'm going to go ahead and install Miniforge. So Miniforge is a Python package manager and Python distribution built in. So it's available on github.com/condaforge with a dash in the middle and then /Miniforge. But alternatively, if you just Google the phrase Miniforge, this was the first result. So you'll be in the right spot. I'm going to go ahead and scroll down to where it says downloads, and we see we have Miniforge 3, and go ahead and download it for Windows. Admittedly, I have never done this before on Windows. I've done it on macOS and Linux more times than I can count, but this is my first time, so this is going to be kind of a learning experience for me. Go ahead and open the installer, and we'll go through it. Agree. I'm going to install just for me, and I would recommend that because that's the way it works on macOS and Linux as well. Let's see, add Miniforge 3 to my path environment variable. Instead, use the, I would like to say yes to that, even though it is very angry at me for saying yes. Register Miniforge 3 is my default, Python 3.9, that sounds good. And clear package cache upon completion, sure. That's going to go ahead and install. I think the path thing is actually pretty important, so please check that. All right, it's been completed, so I'm going to go ahead and click next and finish. So next we're going to want to create a Python environment for your atmospheric science research. So if you go to your start menu, there's a new folder called Miniforge 3, and you get this Miniforge prompt. That's what you're going to want to go ahead and open for now. And you get this scary looking command line window. I promise it's not so scary. This works the same way it does on macOS and Linux. What you're going to want to do in order to create an environment, we're going to type conda create -- name, and then I'm going to call my environment ATMO, and I'm going to be referencing ATMO in the future. So if you want to follow along exactly as I'm doing it, go ahead and type ATMO here. If you feel strongly about naming your environment something other than ATMO, go ahead and act upon those feelings, but just know that in the future, when I say ATMO, you're going to have to type whatever you type here now. So hopefully this works. It is working. Great. I have no idea how long this is going to take. Okay, there we go. It'll just ask you to be sure that this is where you want to put the environment. Go ahead and say yes to this, and it's been created. So now, in order to switch to, right now,
you can see in the shell here that it says base. This is like the default environment that you load into whenever you start. But we've just created an environment called ATMO. And so if you want access to, or to be able to add packages or remove packages to the ATMO environment, you're going to do as it says here, where it says conda activate ATMO. And you can see that now next to the current shell path where it says base here, now it has switched to saying ATMO. So we know that we're in the correct environment. And I'm going to go ahead and install some useful packages for atmospheric science research. So there's one package in particular that's called metpy, which handles all sorts of meteorological calculations. And it also depends on cartopy, matplotlib, xarray, a bunch of other useful things that'll come with it. So I'm going to go ahead and type conda install metpy, and then you're going to want to add a -c conda-forge to the end of it to be sure that you're getting it from the conda-forge repository and not from the Anaconda repository, because conda-forge will have a later version available. So you're going to go ahead and run this, and this will bring in metpy and a bunch of other useful packages into the ATMO environment. So start that fetching. And it's going to print off this very long list. This is basically all of the actions it's about to take. I usually like to scroll to the top of this list where it says environment location, and it says C user SAM Miniforge env ATMO. Just verify that you are actually in the ATMO environment, because this is kind of your, I don't want to say last chance to step back, but this is the last time when it is easy to abort this if you're accidentally in the wrong environment. And I have before installed a bunch of stuff to the wrong environment because I wasn't paying attention. So it's always good to just verify that we want these packages to go to the ATMO environment. So check here to be sure in environment location that you're in the ATMO environment before you say yes here at the bottom. This is where we want them to go. So where it says proceed Y in, go ahead and press Y, and it will now download and install all of these packages. Depending on how long this takes, I might cut the video, but there's a clock in the bottom right corner, so you'll know about how long this should take. All right, that didn't take as long as I thought it was going to, but we've now installed a good list of packages, and we can verify this by typing in conda list, which will list all of the packages of your current environment, which in this case, you can see that we're still in ATMO. So we're listing all of the packages that are currently in ATMO. And we can see that we have things like xarray, which is at its latest version at the time of recording this, that numpy, metpy, and probably cartopy. Yep, there it is. And all of those are the latest versions. So that's a good starting environment for what we're going to be doing in future lessons, I suppose. That feels weird saying lessons. I will, if we need additional packages, I will go through how to install those at the time, although it will probably be something as simple as conda install and then the name. So that's great now that we've got that set up. Now we can set up what's called pyxlma Python, which is Dr. Bruning's Python library for processing LMA data. And this package is different than basically any other package you're going to work with, in the sense that it is not currently hosted on CondaForge or Anaconda, and so you have to install it manually, which can be kind of daunting, but we'll do it together. So you're going to want to go to github.com/deeplycloudy/xlma Python, which is where the source code for this library is hosted. And in order to install one of these packages that isn't hosted anywhere, you're going to want to click here on this green code button, and under HTTPS, you'll have this URL. Go ahead and click this copy button. It'll copy this URL to your pasteboard. And then in the Anaconda prompt, I'm going to go ahead and cd downloads to change directory into my downloads folder. And then I'm going to type in git clone, and I have no idea if this works on Windows, and paste the link. Does not work. Okay. Stand by. All right, so a quick Google search later. Apparently Git has to be installed on Windows. It doesn't just come with Windows, which is unfortunate, but it's an easy enough fix. If you type conda install git-c conda-forge, which is hopefully, again, I've never done this before, so I'm learning. Okay, git. And go ahead and just be sure that you are in ENV's ATMO, and go ahead and hit Y. and this will install Git. All right, and now we can just run the same command that we tried a second ago, git clone, and hooray, okay, I learned something new today. Now that we've got the repository cloned, what this did was it just essentially recreated this structure here on GitHub on our local computer. If we go to downloads, we will actually see a folder called XLMA Python, and here it all is. So I'm going to go ahead and change into this directory by doing cd XLMA Python, and then hit enter. And in order to get the latest version of this package, on GitHub, you'll notice there's two branches, one for master and one for this CF-LMA format. And if we switch to CF-LMA format, you can see that we are 49 commits ahead of master, and it's a much more recent commit date. So we're going to want to do this locally as well. And to do that, we're going to do git checkout cf-lma-format. And you can see we've switched branches. And now we're going to want to do pip install dot. And that will basically say install the current folder that I'm in, which is XLMA Python in this case. You want to be sure before you do a pip command, especially, that you're in the ATMO environment, because pip commands are much harder to undo than conda. And there's no warning like there was with conda, where we got to scroll up and look back at where we were. Pip just immediately starts going. So be careful of that. And also another side note is that typically, pip can be used to install just about anything that you can also install with conda, but for the reasons I just mentioned, less features, less warnings, and less of an ability to undo a mistake, you'll want to try to avoid pip and use conda where possible. In this case, since this is not hosted on Conda Forge or Anaconda, we had to use pip, but just know that going forward that conda is much preferred. So now we have the XLMA library installed in our ATMO environment. So we should be all ready to go for some analysis of lightning data using our Python. So I'm going to go back to Visual Studio Code and get to the fun part, where you can kind of ignore this tutorial, honestly. I'm just going to make a new file, and it'll say select a language to get started. Go ahead and select a language, and I'm going to search for Python, and there we go. It'll ask if you want to install the recommended extensions for Python. Sure, I recommend it. And it will start installing. This is going to give you code highlighting and environment information, etc. Okay, and it's installed. So we can now go back to our file. And if I want to do something like import metpy, and then, oh, that suggestion was wrong, metpy, and then I can scroll down to print hello world. Okay, got that. I'm going to go ahead and save this file, just Control S for that. And I'm going to put it on the desktop, and I'm going to call it test. There we go. So we can see that we're now in user sam desktop test.py. And at the bottom here, we have the select Python interpreter. So I'm going to go ahead and click that. Yours might say something different other than select Python interpreter, but just click it. And in this case, it has not automatically detected that we have Miniforge installed. So it wants me to manually specify a path. If it has detected Miniforge has been installed, then you can just go ahead and click on the Miniforge. But if not, then you can do manually enter a path and then click find. Python, if you go to this PC on the left here, and then you go to your C drive, to users, to your name, and then find Miniforge here, and then go to environments, ATMO, and then this is where it gets a little tricky. Oh, no, actually, you just click on Python here, and it will select interpreter. And we can now see at the bottom, we're using Python 3.10.2 in environment ATMO. And if we just click this little play button here, it will actually run our code for us. or not. Okay. Oh, wait, it worked. Okay, so we get a warning for a valid project directory not found. I honestly don't know what that means, and like up here we also got an error saying Conda was not recognized, but it did run and it did successfully import metpy, because if it didn't, it would have spit out a trace back here saying metpy was not found. So I will look into what that error means and determine if it is worth fixing or not. But as far as I can tell, it has worked okay. I'm very new to Python on Windows and very much prefer Windows, Linux or macOS for it, but it seems to be working. So for those of you using Windows, this is now installed. So let me look at that error. If this is the end of the video, then that means the error wasn't that useful to fix. If I go on to fix the error, then I'll see you in a second, I guess. Okay, so a quick Google search later. It's probably not necessary to fix this, but I'm going to go ahead and do it anyway, just to be safe. From the Miniforge prompt, excuse me, go ahead and type in conda init PowerShell and hit enter. And once you log out of Windows and then log back in, this should not give an error again. And I will verify that. And if it does give an error, then I will continue to go on and explain how to fix it. And if the video ends here, then that means that's the end and it should work. So anyways, thanks for watching.
Okay, howdy everyone. So going to be the macOS tutorial for how to install Python and Visual Studio Code and get set up for atmospheric research. So the first thing that I'm going to install is a code editor, specifically Visual Studio Code, just because it's the one that I prefer and use. If you right now have a working install of Spider, Jupyter, Atom, etc., and you like what you currently have, feel free to skip forward to where I start installing Miniforge, as this is not entirely necessary. If you have and like one of those editors better, this is just for if you either don't have or don't like your current editor. This is what I recommend and what I'll be using. So you're going to want to go to code.visualstudio.com and click this Download Mac Universal button. It will download Visual Studio. And once it's been downloaded, we can go ahead and open the installer. It actually doesn't have an installer, it has just an app icon. So we can drag this app icon to the applications folder, and then it should go to our Launchpad, which, there it is. So now that this is installed, I'm going to go ahead and click open to verify. And for the moment, we can put this away and just minimize it. We'll go back to the setup of that in just a minute once we have Miniforge installed. So Miniforge is a Python package manager, and realize that this is out of the way. Sorry, Python package manager, and allows installation of the aforementioned modules and things that make Python great, and it pulls from the CondaForge repository. So this is located on github.com/conda-forge/miniforge. That's the link to that. Also, if you just Google Miniforge, this should be the first result. I'm going to scroll down to where it says OS 10 for download Miniforge and then to OS 10. So you have two options here, the x86 64-bit and the Apple Silicon or ARM 64. So if you go to your Apple menu here and click About This Mac, you will see where it says Processor, and in my case it says 2.8 gigahertz Intel Core i7. So since it's an Intel Core, I'm going to go for the x86 64 install. If that instead says something like Apple Silicon M1 or something like that, anything Apple Silicon or M series or something, go for the Miniforge ARM 64. In my case, I'm going to go for the x86. The instructions should be the same, with the exception of the name of the file. So just click the one that matches what you're going for. That will download this sh file. So to run that, you're going to go to your Launchpad and then to Other, and then there's this app called Terminal, and you're going to use this a lot. So I'm going to just go ahead and put it in my dock. Go ahead and open it. And you may or may not, when you first open this, get a message that says something like, the default shell is now ZSH. Please run this command. If you get that message, go ahead and run a chsh-s/bin/zsh, which will then prompt you for your password. And you go ahead and enter your password and then let that run. I'm going to go ahead and cancel out of that because I didn't get the message. But if you did get that message, run that command and then type exit and then quit terminal and then restart it. And that will confirm that you have switched to a ZSH shell. I'm not going to really go into why because that's a macOS history thing, but that's a thing that you need to do. So we've downloaded the shell script here that will install Miniforge for us. So to change to your downloads folder, I'm going to go ahead and type CD and then downloads. You can use tab to autocomplete and press enter. And then type in bash, and then it's called Miniforge 3. So type mini and then press tab to autocomplete. It's going to ask for permission. Go ahead and do that. And it should autocomplete, and then go ahead and press enter. So it says, welcome to Miniforge. In order to continue, please review the license agreement. So I'm just going to scroll down to the bottom here. And you're going to want to type yes here. That will accept. For the installation path, you can just leave that blank and it will use the default, which is in your home folder and then to Miniforge 3. And now it will go ahead and install Miniforge for us. It'll get to this stage where it says, do you wish the installer to initialize Miniforge 3 by running conda init? Go ahead and type yes. And now it will say Miniforge 3 is now installed. You'll notice that it says here, for these changes to take effect, please close and reopen your current shell. So I'm going to go ahead and type exit and then quit and then open terminal. And we should see that it says base here next to our name. And that's good. That means that conda has initialized properly and that we're in the base environment, which is the default base environment that you load into whenever you open a shell. We're going to want to create an environment. I'm going to call it ATMO for all of our atmospheric science packages. So in order to do this, I'm going to type conda create --name ATMO. If you feel strongly naming it something other than ATMO, you're more than free to do that, but just be aware that in the future, when I say the word ATMO for when referencing an environment name, you will have to replace it with whatever you're replacing it with now. So go ahead and press enter on that, and it should prompt us to just confirm the location of where we're installing it. There it is. In this case, we're just going to say yes. That's just where it's going to put the environment. And it will say to activate this environment, run conda activate ATMO. So right now we're in the base environment and we have access to all of base's packages and base's version of Python. But in order to switch to using our ATMO environment, you can type in conda activate ATMO. And we'll see that next to our name now, instead of saying base, it now says ATMO. So that means that we're now using the ATMO environment. We have access to the ATMO's packages, and whenever we install packages, they will go to the ATMO environment. So let's go ahead and install some packages. To do this, I'm going to go ahead and type conda install, and the package that I want is called metpy, which handles a lot of meteorological calculations and also brings with it dependencies such as matplotlib and cartopy and xarray, which are packages that you will be quite familiar with in a few days, hopefully. So let me go ahead and type conda install metpy, and then you're going to want to add a -c conda-forge to the end of this to be sure that it's pulling from the conda-forge environment, conda-forge repository, and not the Anaconda repository, so that you get the latest version. So we'll run that. This will take a second to figure out what dependencies it needs, and it's going to list basically these are all of the actions that I'm about to take. If we scroll up to the top, we see where it says environment location. You're going to want to just be sure that it says ATMO here at the end of this, because if it doesn't, it can be a hassle to, if you install a bunch of packages to the wrong environment, it can be a hassle to uninstall them and put them in the correct environment. And speaking from experience here. So if this doesn't say ATMO, go ahead and type no, and then scroll back up. You'll want to do conda activate ATMO and then try this again. In our case, it does say ATMO, so we're good to go. Go ahead and press Y to begin installation. This will take a second. All right, so now we've got our packages installed. The next thing that we're going to want to do is install another package called pyxlma Python, of which this is kind of a special package. It's written by Dr. Bruning at Texas Tech, and it's specifically designed for handling lighting mapping array files. But unfortunately, it is not currently hosted on either CondaForge or Anaconda, so we can't just install it using like conda install pyxlma or something like that. We actually have to install it ourselves manually, which can be kind of difficult, but I'll walk you through it. So first of all, you're going to want to go to the GitHub page for the source code of this, which is github.com/deeplycloudy/xlma-python. And this is the source code of the Python package. So once you're here, in order to install one of these repositories that isn't hosted anywhere, you're going to click this code button here, and then where it says HTTPS, it has this link. Just go ahead and click copy here to copy that, and then go back to your terminal. I'm going to change directory to my downloads folder and CD downloads, and then enter. And then the next thing you want to do is type git clone and then the xlma Python link that you just copied. Should clone in. You actually, on a fresh macOS install, might get a prompt about install the Xcode command line tools. Go ahead and just go along with that. But as soon as you can, run git and do that. So you'll now see in your downloads folder, we have an xlma Python, which is essentially the same thing as what we have on the internet here, except that it is now cloned on our local machine. So that's great. xlma Python has multiple branches, which again, I'm not going to go too far into because that's a rabbit hole I don't feel like going down. But we have master and CF LMA format. The CF LMA format is pretty significantly ahead of master, so we'll want to use that. On the website, we can just change it by clicking, but on the local machine, in order to change the CF LMA format branch, we're going to do git checkout and then CF-LMA-format. And I messed up. We actually need to do CD xlma Python first, and then git checkout CF LMA format. And now, finally, you'll want to be sure that you're in your ATMO environment, because this is much harder to undo installing one of these types of packages than a package from Conda. But since we're good to go ahead. And now you'll want to type pip install dot, and it will install pyxlma. Just kind of a side note, you'll want to avoid using pip as much as possible, just because like pip can be used to install any Conda package, but it's less featureful and more difficult to undo if you make a mistake, which is why you don't really want to use it as much. In this case, we can't use Conda, so we have to use pip. So that's where we're at. So now we've got that installed, we should be good to begin writing some code. So I'm going to open Visual Studio Code, and I'm going to make a new file. It'll say select a language to get started. I'm going to go ahead and do Python. It'll say, do you want to install recommended extensions? Go ahead and install them. This will give you code highlighting and auto suggestions, which are very useful. That'll take a second to install. There we go. So Now I'm going to type in import metpy just to verify that we can import metpy, and then I'm going to print and spell print hello world. Now I'm going to do a command S to save this file. I'm going to save it on the desktop, and I'm going to call it test.py. Save. Go ahead and approve. Did I do downloads by accident? Okay, downloads is fine. At the bottom here where it says Python 3.8.9 64-bit, we need to change this. So if we click here, then it will say selected interpreter user bin Python 3. We're going to want to instead do enter interpreter path and then click find. So this gets a little difficult. Whenever you click find on this, it'll just drop you somewhere. You need to get to your home folder. So I'm going to just click on desktop and then do command and then up arrow key, which will give you into your home folder, which in this case is stgardner4 for me. And then I'm going to go to Miniforge 3 to environments, ATMO, bin, and then scroll and find Python. You can press P to scroll to the P section and Python here. That's what you're going to want to select. So again, that is your home folder to Miniforge 3, environments, ATMO, bin, Python 3. So kind of stick with me here on that. That will get you to the correct environment. And now you'll see at the bottom, we're running Python 3.10 in ATMO. And if we run this, we should get a this is taking a second. There we go. It says hello world, and since it didn't crash, we know that it successfully imported metpy before it did that. So yeah, with that, you should be all good and set up to begin writing your code. So thanks for following along. All right, folks. So today I'm going to go ahead and get started with the Linux install of Visual Studio Code, Miniforge, and kind of getting the environment set up for Python development in what we'll be doing. So first of all, you're going to want to go to code.visualstudio.com. And I should preface this by saying, if you already have a code editor, such as Spider or Jupyter Notebook or something else that you prefer, you can really skip ahead to where I get to installing Miniforge and creating the environment. This is just what I prefer is Visual Studio Code, but it's totally up to you what you want to use. So I'm going to go to code.visualstudio.com, and so on Linux, you're going to want to download the package file for whichever distribution you're currently using. I'm on Pop! OS, which is an Ubuntu derivative, so that's what I'll be using for this video. If you are on Red Hat, Fedora, or CentOS, you'll want to get the RPM. But if you are on a lab computer, which is CentOS, it already has Visual Studio installed in the applications menu, so you can definitely skip this. So I have already downloaded it because my network is not that fast here, so I wanted to do that before the video started. I'm going to change directory into downloads, and I believe, yes, it is the code 1.64.2 dev file. So I'm just going to sudo apt install and /code and enter my password, and it will go ahead and install that for me. All right, so now that Visual Studio Code has been installed, we can go ahead and install Python and the Miniforge package manager. So I'll have the link here. It's github.com/conda-forge/miniforge. Alternatively, if you just Google the word Miniforge, this should be the first result. So that is a thing. You're going to scroll down to where we're in the README and where it says download here. And I'm on x86-64 Linux. If you're on a Linux system and don't know the difference between AMD 64 and ARM 64, use AMD. Even if it's an Intel system, use the AMD download. So I'm just going to go ahead and click save on this. And then I'm going to go back to my terminal, which we're still in downloads here. So you can see we have this Miniforge Linux x86-64 file. You can go ahead and install this by running bash Miniforge 3 and the name of the file. So it'll say review the license agreement, press enter to continue. I'm just going to scroll down to the bottom here and type in yes to accept the terms. The install path, you can just leave this blank and press enter, and it will go ahead and install Miniforge for you. It will ask you if you wish to initialize Miniforge by running conda init. You're going to go ahead and type yes here, and it should initialize Miniforge for your shell. And if you go ahead and type exit and then reopen your terminal, you should see this base here. It will append base somewhere to your shell. This means that this is your active environment. So you have the base environment, and then you can install different environments like I was talking about earlier. So let's go ahead and create an environment. The way we do this is we do conda create -- name, and I'm going to call mine ATMO. And I'll refer to it as ATMO in future videos. So if you would like to follow along word for word, go ahead and use ATMO for your environment name. If you choose something different, just keep that in mind in the future. It will ask you if you want to put it there. You can go ahead and say yes. And now you can do conda activate ATMO to switch to the environment. We can see that it has gone from saying base to now saying ATMO. So we're in the ATMO environment. And I'm going to go ahead and install metpy, which will install a bunch of other things that it depends on, including matplotlib, pandas, and xarray. So to install a package, you would want to do conda install. I'm going to install metpy, and then you want to append a -c conda-forge to the end to be sure that it is fetching from the conda forge repository and you're getting the latest version. I'm going to go ahead and enter that. And it will go ahead and we'll say, do you sure you want to install all of these? Typically, whenever you're installing, especially a lot of packages like this, I like to scroll to the top and just be sure that where it says environment location, you can see that it is environment/ATMO. If this is just a double check to be sure that you're actually putting these packages in the right environment. I have unknowingly installed things to the wrong environment before, so always good to just double check to be sure that it is going where you want it to. In this case, we are installing to the ATMO environment. So we're going to head and scroll right down and press Y for yes, and it will go ahead and install these. I'm on a rather old system, so this is probably going to take a while, and I will probably cut the video for brevity, but you can see based on the clock at the top there, how long this took on a relatively old system. All right, so that actually took less time than I thought it was going to, but we've got all of our packages installed, and now if we do conda list to list the current packages installed, we can see that we have a bunch of useful packages installed, including we have cartopy, the latest version. We have matplotlib, also the latest version. We have metpy, numpy, pandas, and xarray, and that's a really good starting library. So we'll want to install Dr. Bruning's Python library, which is called pyxlma. And it's designed to be a replacement for the XLMA program that was written in IDL. So if you just Google XLMA Python, let's spell it right, hopefully. You will see this will be the first result. It is github.com/deeplycloudy/XLMA Python. So XLMA Python is not like your normal Python package in that it is not currently, at the time of recording this, hosted on Conda Forge or Anaconda. And so you have to download it and install it manually. And so the way that we do this is you click on code here, and then we'll have this clone, and then we'll have this URL. Just go ahead and copy this URL. You can click this little copy button for that. And go back to your terminal. I'm going to go to desktop for the moment. And we can run git clone and then paste in that URL. And we'll do cloning into XLMA Python. And now I'm going to go to cd XLMA Python. So we're changing into the, what we've done is we've cloned this repository from GitHub to our local computer. And now we have set that as our Active Directory. And then in order to get the latest version of this package, we need to change branch. So in GitHub, we can do this visually by changing from master to CFLMA format. And we can see that this is 49 commits ahead of master, so it's pretty significantly far ahead. But on our local machine, in order to do this, we would do git checkout, and then it is cf-lma-format. And now it says we've switched to the CFLMA format from origin. And this is rather important. Before you install a package like this, you'll want to be sure you're in the correct environment, because it can be difficult to remove these if you do it wrong. We can see that we have ATMO here, so we're definitely in the right environment. And we're going to do pip install dot for the install. In general, probably best to avoid using pip where possible, in that it's not as featureful as Conda for installations, and not as easy to remove as Conda packages for installations. But in this case, it's required because pyxlma is not hosted on Conda Forge or the Anaconda repository. So we do what we can with what we have. This has now been installed. So if you want to do any lightning research and follow along with these tutorials, I suppose, and we will be making use of this package quite frequently. Anyway, thanks for watching. Y'all have a great one.